I have to apologize in advance. I found out at 10 o'clock last night I was giving this presentation, so I got somebody else's material. And this morning I got somebody else's computer, so this is going to be kind of figuring things out on the fly a little bit. I guess it was about 5 years ago, Jeff, we did a similar type of thing in a smaller scale here in London. And at that time, we were talking about UK government requirements for BIM Level 2. So everybody familiar with that? And you familiar with BIM Level 3? So this is sort of the idea of, I think, where we are right now, which is this sort of siloed approach where the BIM information, it does produce the 2D documents, but we need some way to share those 2D documents. Simulation happens separately. And then some of the construction activity, what Filippo called the 4D and perhaps 5D pieces, those are happening separately. The way we're working right now, for the most part, throughout these construction projects is in a siloed and file-based approach. And we mix terminology, so it seems like we're doing things that I think are very different than what's happening in the manufacturing world. We work a lot in automotive and aerospace, and I tell you, the way we build cars and airplanes is night and day difference than how we build buildings. And so what's important in other industries is that these things are connected at a data level on a platform. This means that, let me try to make a really simple analogy. I'm kind of doing this off the top of my head. You know, if you work with Microsoft products, for example, right, you've got Excel and you've got Word and you've got PowerPoint, right? Right now what we do is, here's my latest version of the budget in the spreadsheet. It's on this file server, and oh, it's on the cloud, so it's accessible. It's not data yet, it's a file. And it may be shared, but it's not shared very well. And here's my latest PowerPoint presentation, which I got last night at 10. And here's the latest specifications for the project in Word. Those are just files, and we try to create some relationship between them, and we get together and talk about how they're out of sync, and we correct each of them, and then we import and export new versions. But imagine that individual cell in a spreadsheet that's got a price knows exactly where in the Word document the specification is talking about that same product, and they're linked down at that level, and the photograph of the product in the PowerPoint is also linked. Now, when you change that one cell in the spreadsheet, it updates the Word document and the specifications. It changes the picture in the PowerPoint. And all of them are interconnected. Now, that's more of an object-level data integration. It's a really horrible analogy, but I find that I start talking about these things sometimes, and people say, oh, yeah, we have a data-centric system, where I don't think most of us in construction actually do. These are some of the kind of classic problems we're running into in construction. We are doing more and more projects globally and internationally, and when you do that, you're going to have local partners, an architect of record, or a local construction company, or local fabricators you work with. So dealing with multiple disciplines and multiple geographies is challenging. The fabrication and installation is, for most projects today, is pretty siloed and separated from the design process. What the architects and engineers do for legal purposes is pretty separated from what the fabricators and installers do. So the fragmented teams, the communication systems we use, sending around emails, posting on FTP sites, these are all pretty problematic. The idea of BIM Level 3 is really digital continuity, so that when you're making a change to one small element, you don't have to wait for a week for the entire set of drawings to be updated. You have an interconnected system, so that the information that's happening in design has a live connection to what's happening in fabrication, and has a live connection. So I'll show you a case study at the end of one of our customers in the US, working on the US Olympic Museum, and how they did exactly this. The other thing that we're seeing is you know, increased urban density. I think we're, by 2030, we'll be something like 75–80% of the world's population living in urban areas. And then we're seeing investment today in advance of that. So you see London here has a huge amount of international investment. So this means you're not working just locally. You're getting international financing in different locations with different local construction partners, with design teams from different places. And I think, as Filippo alluded to, we're no longer thinking about you know, my particular apartment or my particular building. We're thinking about an urban context, or at least at a district level. So how do you, as an international investor looking at a different city, looking at the lots and the density and the zoning, try to optimize how to deliver that? If you're thinking about this from a manufacturer's point of view, it's completely different than what we've thought of it in terms of construction historically. So the circles represent, I think, the traditional construction approach of, you know, design team is working separately from the supply team. That would be the manufacturers or subcontractors, working separately from the contractor that coordinates everything, separately from the building operations people. And there are these overlaps, but I think most of us aren't yet where Filippo has shown. We are someplace short of that. The overlay with the arrows shows sort of like the way manufacturing thinks of this. They think instead of a digital mock-up. So this isn't just a 4D model. This is more like a digital twin in which physical properties are understood. So if you're showing you know, your MEP diagrams and your structural diagrams, sure, there's clash detection and the things that we're used to, but it's beyond that. We actually know what's moving through the pipes, the pressure of what's moving through the pipes, how it's going to affect the pumps and motors, and how it's going to be distributed, and how many taps are on. We actually understand the cyber-physical environment, the electrical systems, the hydraulic systems, all of that is understood in terms of physics as part of the model. So if you're talking about solar panels in a building, you're understanding time of day and weather conditions and how much power is being generated, how much is being consumed, how much has to be stored in batteries for nighttime. You're understanding all those properties. So when we say digital twin, we don't mean a highly detailed 3D model, and we don't mean a 4D model, we mean something else. So I think we're on the same page about that. So this data platform is what is really critical to make this happen, because for the next decade we're going to be working in different tools, but we have to find a way to interconnect those tools at a data level. And so there's examples here, you know, of again the BIM model and fabrication data and that sort of thing. So what happens with this data integration? You can see in our software interface here what this sort of thing looks like. Is we've broken the building down into a whole series of components, and we can zoom in down to individual levels of doorknobs and pieces, or doors, or the wall that the door is in. These are managed in multiple ways for multiple parties to think about it. How does it get built? How does it perform after it's designed? Just lots of different ways to think about it. But you're able to move in and out and operate at the level that's necessary. Another way to think about this is in terms of the tools you might use. So I would imagine a lot of you guys are using Revit right now. So how do you incorporate that? Do you use IFC to work with somebody that's doing, say, the rebar design, and they're doing it in Tekla? What happens if the site design, the civil engineer is using Bentley's tools? We've got a lot of different tools, and some of the players are better than others in the way IFCs work. So we certainly support those, but we're trying to move to a single source of the truth in which we have something even better than what IFC is offering. So in our case, we have direct both converters and connectors for Revit. So you can work in that platform if you prefer. And if you have a fabricator that's using Tekla, we can integrate with that. But as you bring it together into a single model, you've got to be able to get better performance out of data from multiple sources. So that's the sort of thing we're doing. So when we talk about a platform, we talk about a data-driven solution, we're talking about the new UK requirements for BIM Level 3. This is what we're talking about. Does this make sense to you guys, or is this Greek? I hope I'm not getting too boring and technical. In terms of our solutions, Jonathan will get to those at the end of the day and show you how cool they are. But we address, I think if you go to traditional providers of BIM solutions, they kind of divide their portfolio into these three pieces. Here's some stuff for architects, and here's some stuff for structural designers, and here's stuff for MEP designers. We have a little bit of that just to be able to talk to the rest of the market, but we think in terms of building systems instead of those three traditional categories. So we start with the overall building design. But even there, we're thinking about generative design. We're thinking about conceptual design. We're thinking about multiple ways of designing and not just, let's just jump into the BIM model right away. We think of facade and several other building systems as standalone, that the vertical circulation of stairs and elevators is a system. The facade is a system. The roofing is a system. And the fabricators behind those are really critical players. So we introduced the facade design solution a couple of years ago, and we introduced it both to manufacturers like Permis de Lisa and A&E firms like Arup and Zaha Hadid. Because that partnership's what's really critical, is that the fabricators are using these tools one way and the designers using it a slightly different way, but they're highly connected in the way they work. We also have structural design, we do have MEP systems design, but importantly we're getting into production engineering. This is at the factory level as well as the job site level. So let me jump to a case study to try to explain this, and I'm going to have to jump in and out of my PowerPoint to the videos, unfortunately. This is the U.S. Olympic Museum, and McGrath did the facade for this building. It's a typical kind of challenge where you've got one company doing the structural design. It's a structural steel frame. McGrath is providing the secondary structure that's got to attach to that, and they have to figure out the allowances for how things are changing in the field. As you guys are probably familiar with most of these projects, especially if there's any sort of complication in the way the facade system works, you're going to do a full-scale mock-up. So, you know, I've been doing this for 35, 40 years, and historically we would always do this as a quality control sort of approach. Is whenever the caulking wasn't right or the installation of a panel wasn't done properly, going through the drawings and going through the specs and explaining why it's wrong is challenging. But if you can bring the person over to the full-scale mock-up in the field and say, hey, we all agreed on this, how come it looks different on the building? That's your control standard, right? Well, we need to move, I think, from just this physical mock-up alone to a digital mock-up that we're working with as well. So let me see if I can get out of PowerPoint over to video and back, which is not the best way to do this, but so here is a digital mock-up that's being done in conjunction with a real physical mock-up. The difference here is that every one of these panels understands its context in the system as a whole, but also understands its fabrication requirements. Now, this is not what you get from BIM. You have to have a different level of model to be able to do this. You have to know the thickness of the metal. You have to know how it bends. You have to know what kind of radius you're going to end up with at the bend. You're going to have to know at what point it fails. You're going to have to know whether you have to put that crease diagonally across the panel or not to get extra strength. You're going to have to decide whether you have slotted connections or not. So you have to figure out what's the equipment it's going to be made on, what's the sheet metal break going to be like, and how do these things get fabricated? Oh, we got to produce shop drawings. If we come back and change something in the conceptual design and it ripples through the entire facade and every panel changes, do we have to go back to the shop guy and have all those shop drawings done again? No, we need an interconnected system that understands all that simultaneously. We need a dialogue between the fabricators and the designers so that as adjustments happen over the life of a project, we're always able to respond to them. And again, as Filippo said, let's think about future-proofing the building as well. So maybe these metal panels at some point on the southern face of the building should be replaced with solar panels. Maybe some of them should be switched to perforated panels and there should be a ventilation system. Let's not think of a static system. Let's think about a relationship with a manufacturer in which the elements of the building are dynamic and can be changed over time to get different performance characteristics over the life of the building. So does this make sense, the difference between the digital mock-up and how you use that and the physical mock-up? Okay. It's an extension of a service we already provide, but it's one that's really critical, I think, in distance collaboration and additional knowledge capture. When we get to the building itself, likewise, I think the way we do field execution has got to change. This sort of separation of how the building is going to be built and what the building is, we can't persist with that. Our job as architects and engineers historically has been to precisely define for a legal contract what the end state of the building is going to be at the end of construction at the time of occupancy, right? So that's what the building is. This is what you get in a certain amount of time for a certain amount of money. What we do not do, and what is a real challenge, is the how. How do we go about executing this project? Do we do off-site construction? Is it off-site in a factory, or is it near the construction site in a warehouse? Is it chunked out into these pieces? Do we prefab elements? How do we execute? The how question can impact the cost of the building by 1/4 of the total budget. The what questions that we ask get value engineered out at some point, and we're having really the wrong discussions. We could get a lot more for our service if we showed the impact we could have to how the building's delivered and the impact we can have on overall cost. Let me go to a video for that as well. Okay, so here you see what looks like a traditional BIM model, but it's a lot more. It gets all the way down to the fabrication. It understands the primary structure, secondary structure, and the facade systems. More importantly, as we get into construction on this project, on the Olympic Museum, we did laser scanning throughout construction. What happens with some of these facade systems is accumulated error as you work across the building. There can just be minute differences in the attachment points between primary and secondary. But as these accumulate, you've got to know what the current state is of the installation in the field, and can you make a change in the factory for the panels that are being shipped. We did the same thing on the Barclays Center in New York with SHOP, where we were able to communicate through laser scans in the field exactly what has to be changed in the factory, or whether we can continue with the project as is. So here the cloud point data coming up of so you can see there's safety cables or some diagonal cables that are probably for creating some stability in the frame temporarily until the facade's added to the building. But that laser scan added on top of the original structural model tells us the real state. And now as we're starting to add the panels, we can keep track of what was intended and what's really happening in the field. So that's a different way of working. This means that there's a different role for us to have created not just a static BIM model for 2D documents, but a live model that can be coordinated with the real field conditions. So we add value in construction. I think Filippo made good points about how we can do more with IoT and occupancy, but I don't think we can continue to stand as a profession in the place of only designing the final state of the building. I think we have to think more dynamically about our role in the future. In the 70s and 80s, I found that our role in construction management in the field was substantially reduced as we went to fast-track construction. I'm seeing now with international projects, our role in construction drawings is drastically reduced. If we're not doing the 25% of our work in construction management, if we're not doing the 50% of our work in construction drawings, then what we're doing in conceptual, schematic, and design development is the highest valued part of what we do. And what can we do as a profession to add more value at different stages? I think that's the end of this. Yeah. Oh, look, the video works. So this is what I was talking about. So now we actually know that McGrath uses this particular brake metal press. We know exactly how they make each of the seams. So we know how they make the slotted connections and the regular connections. So does this make sense what I've been saying? I got it midnight last night, so I'm doing the best I can off the top of my head, but I've been around a few job sites, so I do know a little bit about it. Any questions? I think I've got a few minutes for questions. Yeah, in the back.
What do you do for conceptual design? And how do you flow kind of rough geometry all the way through to very specific fabrication geometry?
Yeah. So I don't want to steal Jonathan Asher's thunder, but he's going to blow you away at the end of the day and the next 2 days, getting into the detail. Let's see. If you guys are used to using something like Dynamo or Grasshopper or those generative design tools, and you're used to working in a flow diagram as well as a model, you really love what we're doing in that space, because we have software that can handle much, much larger geometry sets to a higher level of detail and fabrication than most people in the construction industry are used to. But now we have packaged these things in a way Jonathan will explain, so that if you like that generative approach, we have a very strong way of doing that, but it connects to the conceptual model. And if you want to work with maybe you have company standards, it's a kit of parts. You know, we do metal pan steers with poured concrete treads. We do this kind of railing. These are our corporate standards for this kind of building. A contractor or design firm may have those. You can then use those libraries as a way to build the detail at the appropriate time. Our space planning tool will also then generate the use information of the building to know the rentable areas and the use. Our fabrication pieces like facade and MEP systems will keep track of that. So we have sort of a role-based way of working, and it's not as simplified as you're either architecture, structure, or MEP. We imagine that there are dozens of different roles, and it's not just within the AE community. You have external roles with fabricators that you need to interconnect. Our models connect all the way through all of those stages. And so if you're in construction already and putting those panels up, and you have a different idea that's in that flow diagram in the generative design, you can make that change, it'll ripple through. That's the power of being on a true data platform, a true PLM system, and having data integrity between the pieces. Does this make sense? Yeah. Okay. You need to be really loosey-goosey to start. Yeah. And then you need to be super accurate at the end. Well, we do both simultaneously, actually. So, like I say, the stairs, we know exactly what the rise-run ratio is, the nose on the stair. We know all those things, and we expect to repeat them in certain geographies based on certain codes. So some of this is very accurate from the beginning. Some of it is like, I don't know if it's going to be an angular building or a curved building or which facade's the big one. So that's what's really great about this, is you can have a combination of some things you know in a lot of detail, and some things are loosey-goosey, as you said, and then you can bring them all together to the same level of precision. Does that make sense? Okay. There's a question up front.
I'm not sure how that applies to the United Kingdom. I would imagine it's probably a similar problem. In the U.S., we struggle with the architect. You know, contractually, they're not allowed to tell the contractor how to essentially construct a building, but it's such a horrible missed opportunity for us because we can optimize the design. If we did get involved with means and methods, using CATIA, for example, we would be able to add more value and more services. So I see both as a problem and an opportunity that we need to solve.
Yeah. So did you guys hear this? This is a difference between US model and UK model of building. Some of the differences would be structural engineers in UK will do both detailing as well as the structural design. So in the US market, a US structural engineer would do a column and a beam, but not how they connect, no gusset plates, no rebar inside the concrete. In UK and Europe, I'm seeing more integration between the detailers and the basic designers of the systems. I would say historically there's been more precision in the level of the documentation. You know, in the US market, we'll say, you know, anywhere 12 feet along that wall, there should be an outlet. Here, it's going into masonry, and it's going through concrete, and I need it sleeved in advance. It's got to be more precise. I also see a lot of firms, and I think some of the ones here, you have in-house industrial design going on, right? So you've already got a group of people within the firm that are cross-pollinating, and we're thinking about, if this was an industrial product, how would we go about executing it? I think those three differences that I've observed account for some of it. They're both common law systems. It's both case precedent systems. So those are in common. But I'd make an observation about change globally and what's driving it. As we work in China, we find they're able to break a lot of rules that we would have in the US, for example. Labor unions, not really a problem. You know, want to go through that whole housing district with a new rail line, we'll take care of it. Things just get done, okay? So things move very quickly. And I think you can criticize some projects in China by saying, well, the quality's not very good, or this, that, and the other. It's just a matter of time. I mean, think about electronics, right? In Asia right now, how much of these sort of products we take for granted are made there. That's a high level of precision. So the quality of manufacturing, the capability is really quite high, and it's impacting the construction industry. It's just very difficult to export work practices from China to other parts of the world. My personal feeling is that Northern Europe has a great opportunity in the way it influences the rest of the world. I see what happens here in London going immediately to Sydney, going immediately to South Africa, going immediately to the US. There's an interconnection of relationships. But I do see a level of innovation in Northern Europe that is more exploitable. I'm sad as an American architect not to see some leadership in certain areas. But on the other hand, we have Katera starting up, and they're talking about a new way to build buildings. So I think we're seeing pockets of innovation all around the world. But if you look at the industry as a whole, I would say Northern Europe has got a real shot at influencing everybody down the road. One last question? Yeah.
Yeah, it's actually a continuation from what you said before, but with the model you presented, you'll technically be changing the nature of the contract itself that is around each contractor. So have you had a thought or any implications or, I guess, restructuring, say, the standards of codes of conduct or your scope of work as individually, so moving forward it will be something new altogether as a whole unit?
Yeah, I jumped over this pretty quickly in the slides, but in there was this term DFMA, do you know, Design for Manufacture and Assembly? This is a different way to think about construction. Where should I have that? There it is right there in the bottom. If we could speed this whole process up and get to the answer, I would like to see a different type of manufacturing going on in the construction industry. Historically, we have these guys make bathroom fixtures, these guys make light fixtures, these guys make wall panels, these are the manufacturers that make all these pieces and parts. We've got to move away from that. We cannot use the restricted space on a job site to try to handcraft everything like these curiously cut bricks in this groin arch up here. You can't do that. You've got to prefabricate systems using multiple trades in a factory setting, optimizing the environmental conditions, the use of robotics and automation, right? So that's jumping ahead. And I think Katera and some of these other people that you know about are thinking about that sort of thing. I think we have to change the relationship between the AE community and the construction community. But I think the construction community itself has to change. It has to think of a new product. Filippo didn't mention this in his presentation, but let's think about housing as an example, okay? We can't keep building housing the way we're building it. If we look at co-living, it's what the Collaborative here in London and Ollie in New York, and These people that are offering a new type of product, and the real value is the long-time services from the product. It's, hey, I want somebody else to do my laundry or my dry cleaning. I'd like to share a car, not own a car. I don't even want a parking space. Gee, I'd like to go out and do these events. If you are in that kind of market for housing, as opposed to this is my condo or this is my flat, then you own and build the building in a completely different way. So this is the domino. I see two factors driving this change. One is a builder that wants to own and operate the building because the value of the building is going up in time and not down in time. We're used to commissioning a building and watch it slowly devalue as an asset except for the land cost and general real estate costs. This is the opposite, in which your building is highly tied to services and the experiences you're providing. You're more like a theme park. It's like, you know, we are adding more and more attractions and getting more and more money over time. Why would a builder not want the long-time ownership? Instead of turning over the cheapest building possible to get out, why not build the best possible building and stay in? That's got to change. If that changes, now the owner and the builder are joined at the hip or the same entity. And then that builder is going to talk about reinvesting that money into manufactured process because of labor shortage, because of shortage of product in the market for a lot of reasons. But it's got to be a manufactured solution, and it's got to be an asset that increases in value over time for different reasons than the market drives right now. That means that I think architects and engineers have to rethink their position. I don't think the silos we've worked in are sustainable. I think you've got to, as a minimum, know who your fabrication or manufacturing partner is, who's going to work on integrated systems and not individual products. And you've got to realize the intellectual property that comes from that. 15 years back when I worked at Herman Miller, not on chairs and furniture, but on building systems, we hired Nick Grimshaw's office to help us rethink what these products would be. I mean, here's a design firm that's already thinking about creating intellectual property and getting some patents and getting licenses from us at Herman Miller for long-time use. That is what industrial designers always think about, but architects rarely think about. We have to change our business model, have to change our relationship. And those are the three areas I would go after, is the value of the design as intellectual property, the integration of manufacturing and partnering with those manufacturers very closely, and working with builders that will own the asset and see increased value. If you don't go after those portions of the market, I think you'll have a real challenge for yourself. I think that's probably all my time.